Okay, welcome back, and here are some vocabulary related to sets, things you have to know. Equal sets. What are equal sets? Simply, they are two or more sets that have the same elements. So, two or more sets are equal if they have the same elements. As you see here, 0, 1, 2, 3, 4, 5, this is a set that's exactly equal to 1, 3, 4, 2, 5, 0. The same elements, though they are not organized like each other. We say that a set B is a subset of set A. So we mentioned a subset before. And as you see, we use capital letters to represent sets. So we say that the set B is a subset of A if each element of B is in A. For example, if set B includes 1, 2, and 4 and set A includes 1, 2, 4, 8, and 16, then definitely we say that B is subset to A and not A is subset to B. So B, because B includes these elements, is a set that's a part of set A that includes these elements. Cardinal of a set. Cardinal of a set is the number of elements of the set. For example, the cardinal of B here is 3 because it has 3 elements, while the cardinal of A, this is A, is 5 because it includes 5 elements. Now, special kinds of sets. We have special sets. The first special set is called the empty set, represented by phi. Phi. The empty set has no elements. For example, if I have this set defined by x belongs to n, such that x is a solution of the equation x plus 4 equals 0. So the solution of this is minus 4. Minus 4 is not a natural number, while the condition here is that x should be a natural number. For example, let's call this set E. Then here I say that since this equation has no solution in n, then E is an empty set because the solution is rejected. It's not a natural number. So we say that this set E is an empty set. The singleton set. The singleton set, from its name, has only one element from single. Set of divisors of 7, for example, other than 1. You know that 7 is a prime number, so it has two divisors, 1 and itself. If the condition is the set of divisors of 7 other than 1, then all what I have is just 7, which is one single element. So that's why we call this set a singleton. And the pair set, also from its name, it's the set that has two elements, pair. So for example, the set of the square roots of 4. What are the square roots of 4? Either minus 2 or plus 2, just 2 elements. So we call this set a pair set. So the cardinal of the pair set is 2. The cardinal of the singleton set is 1. And the cardinal of the empty set, so the cardinal of the empty set is what? Is 0 because it has no elements. So then the cardinal, the number of elements, is 0. Let's continue what we have to know also. Intersection and union of sets. This is a very important idea. intersection of sets. Take these examples. The set A includes 1, 3, and 5, and the set B includes 3, 4, 5, and 6. Then the intersection between A means I have to search for the common elements intersection that are found in A and B at the same time. So as you see in the Venn diagram here, if I represent A that way, 1, 3, and 5, and B 3, 4, 5, and 6, what's the intersection between them? 3 and 5. If I don't use a Venn diagram, I can put dashes under the common elements 3 and 5. So I will get the intersection between A and B, and note that the intersection of A and B is definitely a subset of each of A and B. It's a part of A and a part of B as well. Now the union of sets. The union means everything in the two sets, all the elements in the two sets without repeating the common elements. As you see here, the union between the set A, which is including 1, 3, and 5, and set B including 3, 4, 5, and 6, collects all the elements in both the sets without repeating the common ones. So I start with A, 1, 3, 5, and see what's missing, 4 and 6. So the union is going to be the set A and what's missing from the set B. So by this I will get a collection of elements that includes A and B at the same time. So A and B must be subset of their union. Okay, and as you see here on the Venn diagram, this is set A, this is set B, and this is the intersection between them. Then the union starts with 1, 3, 5, 4, and 6 without repeating the intersection twice. So to sum up, we say that X belongs to A intersection B. So an element is found in the intersection of two sets if this element is found in A and in B at the same time. While I say that an element belongs to the union of two sets, that means that X is either in A or in B. So when I talk about intersection, I talk about the common elements in both sets. When I talk about the union, I care about elements in A or in B without repeating the common elements. And now let's make things clearer. Here is an example to make things clearer. Consider the sets A from 0 to 9, B, this example was seen before. This includes the set of digits of the decimal system. This set includes the even digits of the decimal system, and this set includes the divisors of 6, as you remember. Here is the representation. You've seen it before using the Venn diagram. This is the largest set A including B and C, and this is the intersection between B and C. Notice that B intersection C is the elements only 2 and 6, so it is a pair set. Notice it is a pair set because it includes only 2 elements. Its cardinal is 2. B union C, the union between B and C, let's start 0, 4, 8, 2, 6, 1, and 3. Exactly. Notice that B and C are subsets of A. So we are going to conclude something, that B intersection A, notice what is B intersection A? It's B itself. B intersection A is B itself because B is a subset of A, and C intersection A is C itself because C is a subset of A, as well as B union A is A, the larger one, and C union A is 8. So if a set, is a subset of a bigger set, the intersection will be the smaller set and the union will be the larger set. Note concerning the cardinal. Notice that the cardinal of B union C, as you see here, it is 7. It's definitely equal to the cardinal of B, which is 5, okay, plus the cardinal of C, which is 4, then we get 9, minus the cardinal of the intersection between B and C, which is 2. And this is a rule as well. So cardinal of B union C is going to be equal to cardinal of B plus cardinal of C minus the cardinal of the intersection set.